All right, here we go. So we are on page 3. Linear inequalities have a lot more solutions than linear equations. Every point in the shaded area is a solution. We're going to graph the inequality y is less than or equal to 1/2 x minus 3. So we're going to start by pretending it's a line and graphing it. So would I start at 1/2 or -3 on the y-axis? Which one? Any ideas? Yeah, -3. So on your y-axis, you want to start at -3. And you're going to do a slope that's a rise of 1 and a run of 2. That's your 1/2 here.
Just like you did the world.
Okay, so we're going to graph that line all the way across. Don't make a short line because, sorry, my computer's in my way. Don't make a short line because that won't show you the entire plane. Like that. Okay? Now, that's not complete because our inequality says y is less than or equal to. So you've got the line, that's the place where y is equal to. Will y be less than, above, or below? Think about your y's. Will y be less than the line if it's above the line or below the line? What does it sound like? Less than, does that sound like above or below? Below, yeah. Okay? So it says here, shade the area less than the line, which is below. Okay? And I'm just going to write the words here in case you didn't get that. This means less than or equal to. Excuse me? I'm pointing at the symbol right here. Yeah, the symbol means less than or equal to.
And notice a solid line because there's an equal sign. Remember, it's a dashed line, there's no equals, just like we did way back. Solid means you can stand on the line. It's equal.
Okay. Next one. It says your turn, so I'm going to have you guys do it, but I want you to think about where do you start? Start with a line. Will you start at -2 or -1? Consider that, and then your slope. All right, so I saw a number of you started at -1. Very good. And then because your slope was not a fraction, you made it -2 over 1. You went down 2 and right 1. Okay. If you want a ruler, I do have a few on that top shelf. It does make nice lines. And I'm going to draw my line. And then I have to figure out where to shade. Did anybody already figure out where to shade? Yeah, so that's interesting that Jesse said the right, because technically I say above or below, but it does look more to be on the right than it does above. So when I say above and below, it might be hard for you to find that area above. So you take your pencil, and if you go straight up, that's going to be the area where you're shading. And Jesse's right, it also does seem to be to the right of the line. All right. So Dr. Simpson made a good point with both of these problems. We have an or equal to on it. This one here is greater than or equal to. And that's why we made a solid line. But if you look at C, take a look at part C, there is no equal to on it, so that's going to affect our graph. It says to start by graphing the line, but y does not equal the line. There's no equal on it. It's just greater than. All right, so since there's no equal to on it, we are going to use a dashed line. Dashed line looks like that. So I'm still going to start at 4. And I'm still going to do a slope that goes up 2 and over 3, like that. But I'm going to make a dashed line. All right, now notice this. This is really important. It says the line is not part of the solution. The line is not part of the solution. It's just like a barrier. Okay. It says shade the area greater than the line. Is greater than the line going to be above or below? I heard a vote for above. That was right. So I'm putting above here, and I'm shading it. So that means every point in the shaded area is a solution. However, if it's on the line, it's not a solution because or equal to is not part of it this time. All right, it is your turn. I want you to start by trying to graph a dashed line and then see if you can figure out where to shade it. Okay. So the tricky thing with this problem was that we did not see the number for the slope, and so I heard some students say, well, that's going to be 1x. X is the same as 1x. And if I want to make 1 into a fraction, well, it could be 1 over 1. And I didn't change a thing there. 1x is the same as x. Start at -2 and do a slope that's up 1 and right 1. Now remember that even though we're only writing on the right side, your line has got to go to the left side as well. So use your ruler and make sure it goes all the way across.
This is way back in that 7, I think that was wrong. But just recalling the skills before. We're going to use it.
Okay? Now, this symbol here, is that a less than or a greater than symbol? It is a less than symbol. Very good. I'm going to label it less than. And I did dash because it didn't have an equal to. And less than, should I shade above it or below it? I heard 2 votes for below. Very good. All right, any questions on that page? Okay. So we are going to check and see if these points are solutions to the inequality. I want to remind you that inequalities have a lot of solutions because any point that's shaded is a solution. But we're not going to graph this one. We're going to do this algebraically. So I'm going to put -1 for the x, and I'm going to put 2 for the y in this inequality. So I'm putting the 2 for the y, greater than 2 times -1 plus 3. That gives me -2. And that gives me a 1. So I get to 2 is greater than 1. Is that true or false? So what I did was I substituted the numbers into this inequality for x and y. So I started by writing the inequality. I put 2 for the y and -1 for the x. And I'm checking to see if it makes a true statement. 2 is greater than 1, which is true. That means that -1, 2 is a solution. It's a solution because it makes a true statement.
Just like we did the other day at the end of the notes. You plug the numbers in. If it's a true statement, it's a solution. If not, it's not a solution.
All right, I'm going to do another one, and then you guys are going to do 2. So the next one, this is for my x, and this is for my y. 0 for x, 3 for y. I'm starting by writing the original inequality. And then substituting 3 for the y and 0 for the x. 2 times 0 is 0. And so I get 3 is greater than 0 plus 3. 3 is greater than 3. That's tricky. What do you guys think? Is 3 greater than 3? I heard some no's. Yeah, you're right. 3 is not greater than 3. They're the same number. So this is false. Because 3 is not greater than 3, 0, 3 is not a solution. All right, so you guys are going to do C and D, and we'll see who needs some help. All right, so I am going to substitute in again. 2x plus 3. I saw some really good work. I saw 2 substituted for the y, and I saw 1 substituted for the x. And I saw you reach the conclusion it's going to be 2 is greater than 5, which is not true. What does that mean? What does that mean about the point 1, 2? It's not a solution. Very good. All right, one more, and then we get to do the easier ones, the graphical ones. All right, so still starting with y is greater than 2x plus 3. I am substituting in. And I get 7 is greater than 2 plus 3. 7 is greater than 5, which is true. What does that mean? The point is a solution. Well done. All right. So, last section. Check if the points are solutions graphically. So I graphed this inequality for you right here. That's this one right here. And I'm going to see if the point is in the shaded region. So 1, 3, is that in the shaded region? Yes or no? Yes, thank you. So yes, it's a solution. Okay, so check all 3 of these to see if they are solutions.
So that's a solution, right?
All right, 6-1, raise your hand if you think yes, it is a solution. Anybody think 6-1 is a solution? I see 2 hands, 3 hands, 4 hands. All right, if you're raising your hand, you are right. 6-1 is a solution because it's in the shaded area. Correct. Oh, good question. Let's get to that one. We'll get to it in a second, okay? 4, 6, is that a solution?
No.
Okay, I heard some people say this is not a solution because it's not in the shaded area. And then the question is the last one, 3, 5.
No.
It's a good question, guys. It's a solid line. If it's a solid line, should we include it?
Yes.
Yes, because solid line means that you could equal the line. If it's a dashed line, then that line is not part of the solution. But this one is. So yes. Okay. So